Hey guys, it's Miss Johnson here, and I'm here to bring you your last notes video for our Flipped Classroom series. It is Unit 9, Note 7 on synthetic division. Our lesson objective today is I can divide polynomials using synthetic division. So we're going to kind of tell you about synthetic division using an example, but before we do that, I have a couple things that I'd like you to note down. Some things to consider when we're working with synthetic division. The first one is we can only use synthetic division when we're dividing by 1x to the first. What that means is if I have something like x minus 3, that'll work. But if I have something like 2x minus 3, I can't do that now because my coefficient is 2. So that one I can't use. Or if I was dividing by something like x squared minus 3, I can't use that either because it's x to the second power. So any x term with any constant, x minus 10, x plus 12, whatever, as long as it's 1x to the first power is okay. The next thing I want you to consider is we're going to put the opposite of the divisor constant in the box. Okay, the opposite. And that's a common mistake that students make is they want to put the number in the box, but they have to take the opposite of it. And the last thing, this is straight from long division as well, but we write remainders out of the divisor. Okay, so we're going to have remainders, and we're going to write them out of the divisor, just like we did with long division. So let's take a look at our first example up at the top. Again, I'm going to look at what I'm dividing by, and I'm going to write the opposite of that number in the box. It's kind of like saying x minus 2 was equal to 0, and I need to add 2 to both sides to give me x equals 2. That number goes in the box. Then, in synthetic division, the nice thing is I'm only concerned about the coefficients. So as long as my polynomial is in standard form, meaning my exponents decrease, and they do here, then I'm just going to list those coefficients out. So I have 5, negative 13, 10, negative 8. So it's just the coefficients in front of the x terms. Leave yourself enough space to write one number's worth and draw a line. We're going to have a line there and a little t there, and we'll talk about what that means. Okay. And now you're probably looking at this going, what the heck do I do with that? Now we go to work. We do a lot of multiplying and adding here, okay? The first number is going to be dropped down and just stay the same. So 5 stays the same. And then I multiply, add, multiply, add, multiply, add. So 2 times 5 gives me 10. That goes under the next number. I add them up. Negative 13 and 10 is negative 3. 2 times negative 3 is negative 6. That goes under my next one. Add them up and I get a 4. And last time, 2 times 4 is 8. That goes under the last number. Negative 8 times 8 is, or plus 8 is 0. Now the reason we have that little line set up at the end is because this is our remainder. Okay, so it's good here because we have no remainder, which is fine. Now, you're probably looking at that and thinking, well, what does that mean? This part is the answer. That's your quotient. Okay, and the way we write it out is this last part is the remainder, which we talked about. Then I just work backwards. The 4 is going to be the constant. The negative 3 is going to be your x term. The 5 is going to be your x squared terms. If there were more, I would just keep going. X to the third, x to the fourth, x to the fifth, and so on. So when I write that out as a quotient, it looks like 5x squared minus 3x plus 4. And I have no remainder, so I don't have to worry about that. And that's my quotient. So let's take a look at the next one. In number 1, I have x squared plus 5x plus 6 divided by x plus 3. Again, I'm going to put the opposite number inside the box, which is negative 3. And now I list my coefficients. This one's a 1, then 5, then 6. Leave yourself enough space, set up your little t-chart, and we go to work. The first number gets dropped down, so that's a 1. And now I multiply and add. Negative 3 times 1 is negative 3. Add them up and I get 2. Negative 3 times 2 is negative 6. Add them up and I get 0. So again, my remainder is 0. Good. That's going to be my constant. That's my x term. So this looks like 1x plus 2, or we could have just written that x plus 2. Let's do number 2. Again, opposite number inside the box. So that's going to be -5. So I have -5 in the box, and I list my coefficients. I have a 1, a 9, and a 20. Leave yourself a little space, draw a line, set up your t. That just reminds you that that last piece is the remainder. That's all that's there for. And now I multiply and add. So the 1 stays the same. Multiply and add, that's -5. Add them together, I get 4. -5 times 4 is -20. Add them together, I get 0. So again, my remainder is 0. Now my constant's 4. My x term is just 1x. So I'd have 1x plus 4 with no remainder, or again, we could just write that x plus 4. We're going to do one more together, number 3. In number 3, the outside number is going to be +3, because I have x minus 3. So the opposite of that is going to be +3 in the box. And then I list my coefficients, 1, 4, -22. Leave a space, set up your t. And now I drop the first number, multiply 3 times 1, which is 3, add it to 4, which is 7, multiply 3 times 7, which is 21, add it to -22, and I get -1. So this time I do have a remainder. That's a constant. That's my x term. So here's how we write this out. I'm going to have x plus 7, and then I need to write my remainder out of what I divided by. So that's -1 over x minus 3. I want you guys to go ahead and work on number 4 on your own. And then don't forget to go take your Schoology quiz. And that's the end of our video for today, and we'll finish the rest up in class tomorrow. Have a great night.